So I'm going to start out by doing a little script that uses a standard sort of base unit that gets mapped three-dimensionally to the surface. And in our discussion today about morphology, it's taking a self-similar unit and then seeing how it changes across that surface. So I have imported a basic surface. I've imported a basic surface to Grasshopper that I just made at random to sort of represent a wall. And I've imported a Grasshopper. We'll use that a little bit later. I'm going to start off by making just a basic cube or box. And I'm just going to make that at 1 by 1 by 1. You can see I have that down here. And that's going to be my unit that I'm building everything within. Okay, so I'm gonna deconstruct this box. Sorry, not deconstruct. Deconstruct the B-rep. So what that'll do, it'll give me the faces, it'll give me the edges, and give me the vertices that I can start to use these to build geometry inside this box. So I'm gonna build a sphere at each one of these vertices, and I'm gonna do it in a way 0.5 radius that I'm gonna do it in a way that I can start to remove these areas of that box, basically sculpting out what I want a sort of standard unit to look like. So if I take these spheres and take a solid difference, the original box and this box, what should be left is this sort of shape in here. Alright. Let's take a look at that more specifically. Okay, so you have this sort of shape right here. Now I want to give it some variation so that when I put this on that surface, I can create some interesting patterns with it. If I tiled this together, it would make these sort of hemispheres across the surface. So the next thing I want to do is create another surface that I'm going to subtract from this. So I want to copy this deconstruct B-rep. So now I have the faces and edges of this new surface. And I want to pull out these top two edges so I can create a sort of saddle shape between these two to connect from one side to the other. So I'm going to get a list item for the edges. And I want this edge up here and this edge up here. So I have to find the right index for that. So that's one of them. Now the other side, I already know is 16 and 23, but you might have to slide yours around to figure out what edges you want if you're making something slightly different. Okay, and then I'm going to also get these endpoints right here. So I could plug in the vertices. And plug in the number that I want. I could get the endpoints of each one of these. Pull out the start and end. Let's do that. So I want start of that one. And the end of the other one. So these 2 points, we're going to draw a line between those and create a sort of surface between them. So I can create this line. And what I'm going to do is I'm going to build a circle around that. So I can build a circle. I'm going to build a circle not at this point, but at the midpoint of that line. So I can get a point on the curve at the middle. You see that's right there. Build this circle. Now I want to adjust the radius so that it matches the length of that line. So that line, I'm not sure how long it is, but I can get its length and divide that by 2. So then I'll have the radius of a circle that matches that. Now, to make this sort of saddle shape, I need that in a vertical direction rather than a horizontal direction. So I'm going to rotate this circle. Let's rotate it 3D. This geometry, the center point is going to be our center point that we made that on. And the axis is going to be that curve. So now we have that circle built on the end of that. We have our 2 curves on either side that we can sweep and make this saddle shape across that. So I'm going to sweep 2 rails. The section will be that geometry. First rail will be this curve. Second rail will be this curve. That didn't work out great. I think one of these we need to reverse the directions. Or flip the curve. Okay, so you can see this is making this saddle shape across here. Now if I want to subtract it from this form, I'm going to need to cap these holes. Okay, let's see what we have here. We have this form down here. We have this form up here that I want to then subtract that out. So I'm going to Boolean difference them, just like I did before. This form, subtract this form. Now if I turn off the previous one, you can see that I've sort of made this swoop cut. It's kind of tangent to this circle down here and cut across it. Now I'm going to make another one just like it, except in the opposite direction down here. So instead of remaking each one of those, I can just move it. And have this B-rep. I can move that in the Z direction. Now go ahead and make that -1. Oh. -1. Now I'll say 0.002. Now I'll explain. Oh, I'll explain why I'm doing that actually. So I'll move it down. And then I'm going to rotate it around so it's not in the same direction, but 90 degrees from that. So I can rotate it. Rotate this geometry. And I need to rotate it in the plane of this form. So if I had a center point, I should be able to do that. So to get a center point, you can get the volume, say the volume of the original box should do. That gives me a center point as a centroid. I can use that to rotate it 90 degrees. So it's like that. So I turn that off, and I want to subtract this. And Boolean difference this. This one now, subtracting this one. Turn these two things off. You can see that it subtracts nicely. Now let's go back to where we moved it down. I said 1.002 because when I tried this before with just the -1, oh, let's just make this a 1. And I made it just a -1, it didn't seem to cut that out. My guess is that these geometries are overlapping on an edge somewhere and it's causing some confusion. So I just moved it ever so slightly. To -2, and it seemed -0.002. 1.002, and it seemed to work out. So that was within a tolerance that I was okay with. You can see we have this fairly complex shape. Now I'm going to use this as you can think of it as a masonry unit, kind of, where we'll stack these up to form a wall. But we don't want to just stack them up as they are. We want them to stretch and bend sort of with a changing morphology over the course of the surface to sort of represent how the surface is bending and morphing as well. So the next thing I'm going to do is use this object in a box morph. So I made this like this so that I can use this component specifically. I have a geometry that was built inside of a box. This box morph will take that geometry with a reference box and convert that geometry to a target box. So it'll stretch and move it till it meets the target box. So we need to get this original box, which I could get from our very first box that we made, or I can just get a bounding box from this. So this will be our geometry, and this will be our reference box. But what we need is all the boxes that are along this surface. So if I come get this surface again, bring it down here, I want to map that to this surface so that it knows how to change this form. So the first thing I need to do is divide up or make the boxes on that surface. So I'm going to divide the domain of that surface. So this gives me a UV count for each one of these. Let's just make it 10 in each direction. And that gives me new domains for each one of these boxes. So I make a surface box on top of the surface with each of these domains. It builds a box, and it builds a thickened box that sort of moves and bends and undulates and stretches with the UV of this surface. Now I can also give it a height. Now say each one of these is 4, just to stretch it out a little bit. And so if I then map this to this target geometry, what you should see pop up in a second is all of these forms sort of articulated on this surface. See, hopefully it won't take so long. So you can kind of see that there. Let's see if I can visualize it a little better for you. So these things are all matching up. And because of the geometry, they kind of make this sort of scalloping Erwin Hauer type screen across this that's bending and morphing with this surface. Now that's interesting in itself, but we can do some more interesting things with that. So what I'm going to do instead of mapping this to each one of these boxes like that, I'm going to make a randomized pattern. I'm going to randomly split this list of these twisted boxes. And it's basically going to split it into 2 lists by some random value. And you can adjust the seed and what percentage is split into the list A or list B as you see fit. And then I'm going to take the twisted box corners, and I believe this is a component from pufferfish, so that if we haven't used that yet, it's a plugin that you should have downloaded already. I'll take one of these lists, I'll break it into corners. Now I want to change the ordering of these corners of all of these points so that it thinks the box is actually rotated. So to do that, I'm just going to change the order of these points, shifting them around. To build a new direction for those. So I'll plug this in, or actually, that's only part of them. We have list B coming down here. We have list A. Let's merge those together. So we should have all of our boxes back together. When I plug that in and it remakes those, you should see that some percentage of these is rotated. Now I'll have to wait for that to update a little bit. So let's turn some of these things off. So what that's actually doing is creating a sort of randomized pattern instead of like being continuous sort of stripes. As one of these rotates, it creates sort of inside blob and outside blob that is randomly changing across that surface. Which is interesting to see how that works. And because of the way we made that geometry, it always aligns. No matter which way you rotate that surface aligns to the one next to it. It just creates a different sort of figure of how that bends through that. So I think that's it. That's showing a little bit how you would surface map or box morph a standard unit into a wide variety of units. It doesn't matter what that unit is, you should be able to morph it from the original box to surface boxes, so you can play around with the different types of things that you can put into that. I think that's it.